We know now how to evaluate trigonometric functions at acute angles. Now, very naturally, next task is to evaluate trigonometric functions at non-acute angles. As we know, if we place a non-acute angle in standard position, its terminal side can be in the second quadrant, or third, or fourth, or maybe a quadrantal angle. That means its terminal side maybe coincide with one of the axes, either x or y axis. So let's look at some non-acute angles, and we're going to see how to make it a little bit easier for us. So we first assume that the angle is not acute. It's also its terminal side is not coincide with the x or y axis. That means it's not quadrantal. So it's not a quadrantal angle. It is not an acute angle. That means the terminal side must be in the second, third, or fourth quadrant. So it will be one of the three cases. We want to define an acute angle that is called the reference angle. So the reference angle, let's see. It must be a positive and must be an acute angle. It is formed by the terminal side of the given angle and the x-axis. Okay, so that is the definition. So let's use the definition to find the reference angle of some given angles. So the first one, let's look at this. This is an angle in the second quadrant. So using the definition, this angle theta, right, in standard position, and it's in the second quadrant. Its reference angle is the angle formed by the terminal side and the x-axis. And it is acute, right? You see? Remember the definition, it is the angle formed by the terminal side and the x-axis. Yeah, so you look for the positive acute angle. So that is the reference angle. We denote it by theta prime. Okay, let's look at another case. Suppose it is an angle in the third quadrant. The third quadrant, this is an angle in a standard position. So theta is given here. This is the angle theta in the third quadrant. And what's the reference angle for this angle theta? The reference angle, let's look for the terminal side, is the acute angle formed by the terminal side and the x-axis. So this one, I had it in blue, the theta prime is that acute angle, right? So you look for the acute angle formed by terminal side and x-axis. And the third case, what if the angle is in the fourth quadrant? Yeah, again, let's look for the reference angle. So this terminal side is in the fourth quadrant. We decide the reference angle by looking for this acute angle formed by the terminal side and the x-axis. Yeah, so this terminal side and x-axis. So that is the theta prime, which is acute. So we can find always an acute angle, right? Using this definition, so we can always find the reference angle of a given angle. So the reference angle is acute, and we know the trigonometric function values for the reference angle must be positive. However, the trigonometric function values for theta is not necessarily positive because the theta in the first or second or the third, yeah. So the theta can be in any one of the 4 quadrants. That's why the trigonometric function values may not always be positive. However, for the reference angle, which is an acute angle, the trigonometric function values are always positive, right? So that means for the non-acute angle, when we determine the trig function values, we need to address the sign. But before that, let's just practice finding the reference angles for some given angles. So here is a 310-degree angle. So this 310-degree angle, a plot of this angle, let's place it in the standard position. You see, it's definitely bigger than 180 and even 270, right? You go a little further, then that's 310, but it's less than 360. So it's not a complete rotation. So, right, this is an angle in the fourth quadrant. For this 310-degree angle, what is the reference angle? The reference angle, by definition, it is the acute angle formed by the terminal side and the x-axis, right? Must be this one. So how do we figure out the degree measure of the reference angle? So we call it theta prime. That's only the name of the reference angle. But to find it, look, a complete rotation is 360. So the acute angle must be 360 degree minus 310, which is a 50-degree angle. So theta prime is a 50-degree angle. Now let's look at another problem. The second angle given is a negative angle. It is negative 161 degrees. And if we place this angle in a standard position, so in the standard position, you see it's negative. That means this is the clockwise rotation. Okay, so we go here clockwise, but not go all the way to 180 because it's negative 161. So we go up to this. And then, so it's in the standard position and the terminal side is in the third quadrant. Yeah, third quadrant. But if you keep going, you can go to negative 180, a little further. So, but now let's, we first get this angle, which is a negative 161. What's the reference? The reference angle is the terminal side is formed by terminal side and the x-axis And it must be an acute angle here. So theta prime. So how do we get theta prime? Theta prime is that acute angle. It can be calculated if we subtract 161 from 180 degrees. So that's a 19-degree angle. Yeah, so for both problems, we have found their reference angles.